So, solving equations. You guys have been solving equations for a long time. Even these quadratic equations you've been solving. We're going to get to higher degrees like x to the third. Or possibly x to the fourth. We'll see. But would you guys agree? I hope you agree. Didn't we just barely learn how to do this from section 1.3, that last assignment we did? So you don't have to answer out loud, but I want you to gauge your level of understanding. So this is just a personal yes or no question. If I wrote an equation like y equals on the board right now, could you tell me what the zeros are? Okay. That's what you need to ask yourself. If I wrote an equation, could you factor it and tell me the zeros? I hope most of you are saying, yeah, I could probably do that, because we've been practicing this for 2 or 3 days. But the nice thing is, if you guys can factor and find zeros, guess what you can do? You can solve equations, because it is exactly the same process.
Okay. This one, for example. This looks pretty easy to do, right? If it was y equals x squared plus 7x plus 10, you factor it in x plus 2 times x plus 5, and then that'll tell you the zeros are x equals negative 2, x equals negative 5. We've done this, right? Well, let's just apply that to a slightly different situation. Instead of having y equals, let's call it 0 equals. Write that down. 0 equals
x squared plus 7x plus 10. These are the type of equations you're going to be solving. Instead of having y equals that we're going to graph, it's going to be 0 equals, and then you're going to have some kind of a polynomial. They're not all going to be quadratic like this one. They could be cubic or quartic.
Guess what the first step is? It's essentially the same thing as finding the zeros. And what's the first step of finding zeros? Factor. So let's factor this. So, again, the method, whatever's in front of x squared, which in this case is 1, you multiply that by the last number. 1 times 10 is 10. What multiplies to 10 adds to 7? Oh, come on. 2 and 5, right? So we have the 2, we have the 5. You already know how it factors because you can see it up here, but you need to get used to going through this process real quick. You switch the 7x into 2x and 5x. Group the first 2 terms. From that, you factor out an x. That leaves you with x plus 2. From the second grouping, you can take out a 5, and that leaves you with x plus 2. So your 2 factors are x plus 2 times x plus 5. It may not be 100% necessary in this particular problem, but you do need to get used to doing this because in the next unit we're going to see much more complicated problems to solve. So I want you to get used to doing this step 2. You set each factor. Now let me stop there. What do I mean by factor? What are the factors? X plus 2 is a factor. X plus 5. So you take each factor and set it equal to 0. So I'm going to take the x plus 2, set it equal to 0. And then I'm going to take the x plus 5 and set that equal to 0. And then you just solve those 2 simple equations. If x plus 2 equals 0, x has to equal negative 2. If x plus 5 equals 0, then x has to equal negative 5. Those are the 2 solutions. So right now we know 3 words that mean the exact same thing. Zeros are the same as what? Zeros are the same as x-intercepts, but now we've seen also that they're the same as solutions to the equation if it equals 0. They all mean the same thing. Zeros, solutions, x-intercepts. All the same. Okay? So let's take a look at problem 1 on your worksheet. X squared plus 10x plus 25. Go ahead and try question number 1. Solve by factoring. My goal is that we get a majority of this worksheet done in class so you have less to do on your own.
So it did factor, right? Didn't this factor into what two factors? X plus 5, X plus 5. All right, this doesn't happen very often. We ended up having two identical factors. It happens from time to time. But you still proceed like normal. You take each factor, set it equal to 0. In this case, they're both the same. So you're really going to get one solution here. X equals -5. Now, if we were talking graph here, I'm not asking you to graph these, but if we were to look at the graph of this, what does it mean that X plus 5 appears twice? What does that mean?
It has multiplicity too. It bounces.
Okay, so not that you need to do this on your assignment, but if you were to graph this, the 0 would be here at -5, and the parabola would just bounce off at -5 right there. Anywho, skip question 2 for just a second, because that's a little bit different.
Well, we're going to get to that as well. Try question 3. If you've gotten one done, try question 3. We're going to get to question 2 and question 4 here in just a sec.
What was it? 0 equals x squared plus 4x plus 3? Is that what it was? Alright, so it factors into x plus 3 times x plus 1. So then when you set each factor equals 0, x plus 3 equals 0, x plus 1 equals 0, you get x equals -3, x equals.
Not so bad so far, I hope. Why did we skip 2? Explain to me what the difference is on question 2 than question 1 and 3. There is a difference, right? There's only 2 terms. And in particular, which one is missing? The one in the middle that has the x with it, right? That's called a linear term. This is a quadratic term. This is a linear term. This is a constant. So can you find another problem on there that's kind of like question 2? Question 6, these two are pretty similar. This is a new section and note. Well, it's still under this subtopic of factoring, but it's a little bit different type of factoring. So let's get back to notes.
This is still objective 1.
Shoot, am I recording? I paused it for a second. Oh, good. Woo. So, mathematically speaking, what does the word difference mean in math? Subtraction, right? So take a look at question 2. Are those two things subtracting? What about question 6? Are those two things subtracting? So those are differences, right? You're taking the difference. Now, particularly it says difference of squares. That means you need to be subtracting 2 things that are being squared. Now, both of them have an x squared. So obviously x is being squared, right? But what's question 2? X squared minus what? X squared minus 25. Is 25 the result of something being squared? 5, right? What about question 6? 4 is the result of 2
being squared. You need to start recognizing instances of difference of squares. You really do.
Difference means what? Subtraction. Difference of squares means both terms that are being subtracted are perfect squares. So here's the pattern. This is something you absolutely have to know. You have to have it memorized. There is no other way about it.
Some of you might have been taught this last year. If you were, great. If not, that's also okay. We're learning it now. So
This is just in general. We're going to get to some specific examples here in a second. But in general, if you're subtracting two terms that are perfect squares, a squared minus b squared, you can factor that into this kind of a pattern. A plus b, a minus b. So this one, for example, x squared minus 4. You can think about it like this. X squared minus 2 squared. Now it's difference of squares. X is being squared, 2 is being squared. So if you follow this pattern, you're going to have two sets of parentheses, and they're nearly identical except one's plus, one's minus in the middle. What are the terms going to be inside there? X plus 2 and x minus 2. Pretty easy. That's how you factor difference of squares. So just a couple I want you to try here. X squared minus 16, x squared minus 49. Should take you all of about 5 seconds. X squared minus 16, what does that factor into? X plus 4, x minus 4. What about x squared minus 49? X plus 7, x minus 7. All right. What about this one? Think carefully before answering.
Don't write anything down yet, because it's wrong. Trust me.
the phrase is difference of squares. These aren't subtracting, right? They're going to try to fool you with stuff like this. X squared plus 64 doesn't factor because it's not difference
Of squares.
There's nothing you can do to factor this. This is not factorable. So you just got to really just watch and remember the phrase. And not just remember the phrase, you got to know what the phrase means. Difference means what?
Subtraction. That's the first thing they'll try to screw you up on
is not giving you a subtraction problem. The second thing is
they'll give you a subtraction problem, so you think, all right, this is
difference of squares. But you got to really think, is that right there
the difference of squares.
what's wrong with it? It's not a 21's not a perfect square,
So that one's also not
factorable? So knowing that, let's take a look at question 2 here. So question 2 is x squared minus 4 is equal to 0. And I want you to solve this by factoring. And in particular, we're going to factor using that difference of squares pattern. So x squared minus 4, what does it factor into? X plus 2, x minus 2. So these are pretty simple problems. These are really easy to factor. Once you've got it factored,
like this.
What are the two solutions from there?
this one right here is going to give you a solution of x equals negative 2. This one's going to give you a solution of x equals positive 2. Now, as easy as that was, honestly, that's not the way I would do this problem. We did it this way because the directions said to solve by factoring, but I think there's a quicker way. remind me again what was different about this problem than all the others. Wasn't that middle term missing? You guys, you got to watch out for that, because if that middle term is missing, there's so much easier way to solve this. Let's try again. X squared minus 4 equals 0. What if you just added 4 to both sides? What is that going to do? What did that accomplish? How do you get rid of x squared? You square root both sides. What's the square root of 4? Ugh. Or negative 2, right? Don't you remember the plus or minus? Square root of 4 is plus or minus 2. Do we get the same answers? The reason you guys actually should know this method is what if by chance you get this kind of a problem. Solve x squared minus 6 equals 0. Can you even solve that using difference of squares? No. So what method are you going to have to use? You're going to have to use this method. Okay? So if you're ever missing that middle term, I would use the square root method rather than difference of squares. Anyway, what about question 6? Try it.
Question 6. Or was that just question 6 right there? Sorry, question 2. Try question 2.
So this was question 6. All right. So you guys try question 2. So on question 4, the problem really isn't x to the third. Check this out. What if I ask you to solve this one? 0 equals x to the third, I don't know, minus x squared minus 6x. I want you to write this down in your notes.
Here, the x to the third isn't a super huge deal.
Why not? What can we do? You can factor out an x, right? That's going to leave you with x squared minus x minus 6. And then to finish this off, we factor the x squared minus x minus 6. That factors in x minus 3 times x plus 2. I know I'm going kind of quick here, but we're slowly running short on time. And then wouldn't the 3, aren't there going to be 3 solutions now? What are the 3 solutions? X equals 0, x equals 3, and x equals negative 2. So we can still work with an x to the third as long as we can factor out an x from all the terms. But if you notice on number 4, can you take out an x from everything? So that is kind of a problem. So let's just cross that one off, huh? No! Don't you dare cross that off. So, what? Tell me, Mr. Cougar over. Tell me what? Andrew. C. Seating chart's working. Read me number 4 if you would, please.
Yeah, x cubed minus 4x squared minus x plus 4
equals 0. Okay. This is question 4. I want you to write this down. If it has 4 terms and no common factors that we can factor out, which is what we have here. We have 4 terms and there are no common factors, then factor by grouping is what it's called. Factor by grouping. Guess what? This is not a new method of factoring. You already know this method. Trust me. You know this method quite well, as a matter of fact. Here's a quick little thing of factoring by grouping. This one right here, you guys could factor pretty quickly, right? X squared plus 7x plus 10. How would this factor? X plus 5, x plus 2, right? So it's pretty easy to factor, but the way I've been showing you, the way I've always been showing you, is the factor by grouping method. 2x plus 5x. Does this look familiar? Well, take a look at what we have there. Does that have 4 terms, yes or no? Does it have a common factor for all of them? It doesn't, right? But what did we do at this point? If it had 4 terms, what did we do? Didn't we group the first 2 terms together? And didn't we group the last 2 terms together? That's all this is, factoring by grouping, is you group the first 2, you group the last 2. From the first group you get out the x, that leaves you with x plus 2. From the last group you get out the 5, that leaves you with x plus 2. So your factors are x plus 2 and x plus 5. That's the process of factoring by grouping. So on our problem here, question 4, you're going to group the first 2 terms, x to the 3rd minus 4x squared, and then you're going to group the last 2 terms. And we got to factor out common factors just from the groups, the individual groups, not from the whole thing. So from the first grouping, what can we take out of that first grouping? X squared, that leaves you with x minus 4. Now here's one thing that students often get wrong. You always have to factor something out. If you take a look, x and 4 doesn't look like they have anything in common. You still have to factor something out. Negative 1. You always are going to either factor out a 1 or a negative 1, if nothing else. In this case, it has to be a negative 1 because you don't want to have a negative x in there. So if you factor out a negative 1, that leaves you with x minus, why minus? The negative changed the sign in there, exactly, x minus 4. So x minus 4 is one of your factors. The other factor is x squared minus 1. And we keep going like normal. We set each factor equal to 0. X minus 4 equals 0. X squared minus 1 equals 0. What do we do with x minus 4 equals 0? What's the solution to that? X equals 4. All I did, once I had it in these 2 factors, I just took each factor, set it equal to 0. How do we solve x squared minus 1 equals 0? Add 1 and then square root it. So this is going to be x squared equals positive 1. If you square root positive 1, what's the square root of 1? Oh! No! What's the square root of 1? Plus or minus 1. You guys need to get used to remembering that. If not, you're going to miss half the points. If you said x equals 1, that's only half the answers. So x equals plus or minus 1. How many answers did we get?
Yeah, 3. Why did we have to get 3 solutions? It's a 3rd degree polynomial. Okay. So scan real quick on the front side. Do you see any other problems on the front side that resemble question 4? All right, you 7. And remember, you always have to factor something out of the groups. If it doesn't look like there's a common factor, what do you factor out? A 1 or a negative 1 if you need to factor out a negative 1.